So in this video we're going to talk about how to solve a couple of trig equations by factoring. So in both cases here we have equations that normally we would have to factor to solve, and just because we add trig functions into it, it doesn't change anything that we're going to do along the way. It just means that we have a trig function now. So for this one here, for the 2 cosine squared x plus cosine x minus 1, the first thing that I'm always going to do is I'm going to substitute in for the cosine of x. I'm going to let w equal the cosine of x. And so what that allows me to do is now I have 2w squared plus w minus 1 equals 0. So it just kind of allows me, it's not really a necessary step, but it allows me to sort of simplify the equation a little bit. And now I can kind of go back to my days in Algebra 2 or Algebra 1 whenever I learned factoring. And all I have to do here is factor this quadratic expression here, quadratic equation. And so there's literally a million different ways in which a lot of different methods which teachers have taught how to factor that. The one that I like is grouping. If you needed to follow a video on that, I believe that there's one in my YouTube channel here. But I'm just going to go ahead and factor this part here. And this is going to come out to be 2w minus 1 times w plus 1. And that's going to equal 0. And then according to our zero product property, we end up with 2w minus 1 equals 0, which means that w equals 1/2. We also get w plus 1 equals 0, which means w could equal a -1. All right, well now w, remember, w is not just w. W was the cosine of x. So what this means is that we can say that the cosine of x is equal to 1/2. And over here we can say that the cosine of x is equal to a -1. So we didn't start with any kind of restrictions here. So if we were going to look for all the possible values of x at which the cosine is equal to 1/2, well, the cosine is going to equal 1/2 when x is equal to pi over 3, not pi over 2, pi over 3. And when x is equal to 5 pi over 3. And if we were looking only for the values between 0 and 2 pi, then those would be both of our solutions for this expression here. But since we're looking for all the possible solutions, we would have to make sure we put plus 2 pi n, and same thing here, plus 2 pi n. That's going to account for all additional rotations. Okay, now remember, if we were restricted from 0 to 2 pi, we wouldn't need that. But because we're unrestricted here, we do need it. And the last one is this here, the cosine of x equals a -1. Well, that comes when x is equal to pi. And since, again, it's going to have to account for all additional rotations, we'll have to add plus 2 pi n. So if we wanted all possible values of the cosine of x, that satisfy the equation 2 cosine squared x plus cosine x minus 1 equals 0, it's going to be anything covered by any of these three solutions here. For our second equation over here, this is not necessarily a quadratic equation, but it's still one that we're going to want to factor. So if we look at each of these expressions separated by the subtraction sign, we can see that what they have in common is the tangent of x. Okay, that means that the tangent of x is going to be my greatest common factor. So that's what I'm going to take out. So I'm going to say that the tangent of x times sine of x minus 3 is equal to 0. Okay, and I'm going to have to then solve each of these here. So for the first one, we're going to say that tangent of x is equal to 0, and again, this is using our zero product property, and that the sine of x minus 3 is also equal to 0. So here we're going to get tangent is equal to 0 when x is equal to 0, and again when x is equal to pi. Over here we have the straight mark there. We have the sine of x minus 3. This is going to mean that the sine of x is equal to 3. And that's actually not going to be possible. That's going to be an undefined answer or no solution here. And that's because the sign of x can never be greater than 1 or less than -1. So this here is going to give us a no solution. All right, so that's not going to help us at all. That means that part of it's done. Well, over here, again, if we were restricted, if we were only looking for values between 0 and 2 pi, then this would be it. But because we did not restrict our possible answers here, we're going to have to say plus pi n and plus pi n. And we use pi rather than 2 pi because the period for the tangent is just 1 pi. Now, the last thing we notice here is that if we have both of these here, all the solutions for this first one are going to overlap with all the solutions for this second one down here. So we don't actually need both. We can get rid of this one because if I take 0 plus pi n, I'm going to get pi. If I get 0 plus 2 pi, I'm going to get same things if n was 1 in the second one here. So really the only solution I end up with here is 0 plus pi n. Or in other words, I could really just say x is equal to pi n, where n is the number of rotations. I hope this video helps, and good luck.